I want to present to you my scientific project about the recycling of metallurgical slags for wastewater treatment. There are several large steel companies in Russia that produce cast iron, steel, and steel products. In 2019, companies produced about 59 million tons of steel. And the major waste of the ferrous metallurgy industry are steelmaking slag and blast furnace slag. The total mass of metallurgical slags formed in Russia in 2019 is up to 5.4 billion tons. Because of the long history of the industry, major chemical and physical characteristics of the slags were investigated, which helps to implement the materials in some production processes. For example, blast furnace slag can be used in Portland cement, but not all of the fractions of the slag are suitable for further implementation. The major part of the waste is fraction smaller than 10 millimeters, and it's not applicable in any processes and stored on the enterprise's territory. Novolipetsk Steel is one of the largest steel producers in Russia. It accounts for 22% of total steel production. About 2 million tons of slags are formed annually in production process of steel. For use in further processes, the slag is cooled and the metal components are separated. Then the material is crushed and separated into fractions. Large fractions are sold for use in, for example, road construction, but about 1 million ton of fine fraction slag is not used and cannot be sold. To find a solution to the problem, I have studied several works, and some of them describe the use of electric steelmaking slag in wastewater treatment process from various pollutants. For example, electric steelmaking slag can be used in purification of wastewater from iron and zinc ions. Also, another work described the use of slag in the treatment of water from cooling mixtures. The purpose of my research work was to study the properties of slag, of fine fractions, to reveal the ability to purify wastewater from various components. To achieve this goal, it was necessary to go through the steps presented on the slide, and let's consider them in more details. To study the properties of steelmaking slag, two fractions of material were selected. First of all, it was necessary to define the elemental composition of the material, and studies on the elemental composition of slag show that the main components is calcium compounds, the concentration of which ranges from 44% to 48%. Also, there are some heavy metal compounds in the material, such as iron, manganese, and others. To exclude the possibility of the contamination of treating water, the desorption experiment was held. Due to the result of the experiment, the leaching of heavy metal compounds doesn't occur. That makes it possible to apply the material in water treatment processes. But the results also show that the concentration of calcium compounds is high in solutions. That leads to a change in the pH level toward strongly alkaline solution, as well as increase in total hardness of solutions. Some scientific works highlight the possibility of using various slag as sorbents. And in order to evaluate the possibility of sorption on the slag, it was necessary to look at the particle surface and measure the surface area. On the slide, you can see the images of the surface of the two fractions. And the particle have a developed surface, which allows us to assume the presence of sorption properties of the material. Also, we measured the surface area of the fractions, and smaller fraction number 1, has about 5.6 square meters per gram surface area, and larger fractions, fraction 2, has about 3.5 square meters per gram surface area. Natural and artificial materials used as sorbents have a significantly higher surface area than the slag. The area of such sorbents can range from 30 to 1,500 square meters per gram. But materials used for selective sorption, such as iron shavings, can have a surface area from 15 to 58 square centimeters per gram. Therefore, it can be assumed that the slag can sorb certain substances from solutions. And to study the possibility of removing metal cations from water, experiments were carried out under static conditions. The line graph on the left shows the changes in the pH level depending on the mass of the slag additive, and the left line graph on the right shows the change in the efficiency of cleaning solutions depending from slag additive. As can be seen from the graph, the efficiency of cleaning solution from the metal cations is up to 99%. The efficiency of cleaning solution with slag fraction 2 increases unevenly due to the larger particle size, and as a result, the interaction with the solution is lower. Also, during the experiment, sediment was found in the solutions after the interaction with slag. The sediment was studied and the analysis showed a high concentration of the metal compounds in the sediment. And this analysis helps us to understand that the purification process of solutions occurred due to an increase in the pH level and the sedimentation of insoluble metal compounds. And the sorption mechanism makes a small contribution to the purification of solutions. In order to successfully use steelmaking slag in wastewater treatment process, it's necessary to carry out several tests in the future. Firstly, we need to measure the optimal time for the interaction of solution with slag. And secondly, an experiment on the purification of model solution with several components needs to be done. And also, we need to study the composition of the sludge obtained after treatment to determine the possibility of its disposal. And why it's also important to use the slag in further processes. The iron and steel industry has been operating for centuries, and its impact on cities, communities, and natural environment is profound. As we all know, in 2015, the UN presented the document, the Sustainable Development Agenda. This document contains 17 goals that are devoted to the main problems of society and due to the implementation of which each country should strive. One of the 17 Sustainable Development Goals is the assurance of sustainable consumption and production patterns. It's SDG 12. Several propositions were highlighted to achieve this goal, and one of the propositions is to reduce production and consumption waste by recycling, reducing, and reuse of them. By using slag in wastewater treatment processes, we solve the problem of accumulation and storage of large amount of industrial waste, which is in line with the SDG 12. Also, by using steelmaking slag in wastewater treatment, companies can influence the achievement of SDG 6, one of the targets of which is to minimize the release of chemicals into water bodies. And since the slags are stored in the open area of enterprises, this affects the quality of the air and the surrounding land. By reducing the storage area and reclaiming this area, we also fulfill the SDG 15, aimed at the rational use of land resources. Thank you very much